Hello students, welcome to your video lesson, your first video lesson from chapter 6. We're going to sort of shift gears a little bit in chapter 6. We just finished chapter 5 talking about limits, talking about rational functions, talking about asymptotes, horizontal and vertical and all that kind of stuff. Now in chapter 6, we are going to jump back into the world of trigonometry. Okay, so what I've drawn here for you, you hopefully recognize. This lovely thing here is your unit circle. Okay, so we should be relatively familiar with the unit circle. We should have one that's all filled out in our notes. That's something that you're going to want to have available for the majority of this chapter. Okay, we're going to be asking a lot of questions about the unit circle. So go ahead and do have that out and available for you. And hopefully you have it all labeled with, our pi over 4 and our pi over 2, pi over 6. What am I doing? Pi over 6 and pi over 4, and pi over 3, and all these things. Okay, we're gonna need a lot of stuff like this in chapter 6. All right. So just get that out, get refamiliarized with that. And then we're gonna turn in our books to page 267. We're going to start talking about trigonometric equations. I know y'all love it so much. Trigonometric. I don't know how many times you want me to say it, but anyway, there you go. Solving trig equations is what we're going to work on today. Okay, we're going to try to solve trig equations. We're going to start with number 1. And number 1 shows us a graph. Okay, it shows us a graph. It says we begin with the graphs of y equals sine of x. So hopefully you remember we used to graph sine of x and cosine of x, where x was the angle and then the sine or the cosine. It was our periodic functions, right? Up, down, up, down, up, down, up, down, forever like this. And then they've also graphed for you a horizontal line at y equals 1/2. Okay, and what they're basically asking us to do is to use these two graphs, the sine of x and then y equals 1/2, to try to solve this equation right here. Okay, and just a reminder, when we solve equations, we are going to hopefully end with something that says x equals. Okay, we're going to end with something that says x equals. It's going to tell us a value of x that makes this equation true. Okay, so you're sort of thinking like whatever's in this parentheses is sort of a question mark right now. It's the unknown value, right? Sine of what is equal to 1/2, okay? So what the start with in letter A is just sort of look and analyze this graph and understand why this graph allows us to see that this equation is going to have multiple answers, right? This equation is going to have multiple answers, even though they have restricted the domain, so they just want answers that are between 0 and 2 pi, which is right out here. They want the answers between 0 and 2 pi, okay? 0 to 2 pi is a restricted domain. All we're worried about is that. But there's still multiple answers because I see two different spots where these two graphs intersect, where the sine of x graph takes a value that is equal to 1/2, okay? And those two are right here and right here. Okay, these two x values, if I drop them down like right about there and right about there, obviously my graph isn't perfect, but these two x values are points of intersection for these two graphs, okay? So these are both locations where the sine of x is equal to 1/2. So when they ask us, explain why this graph shows multiple solutions, we just say, well, that's because the lines intersect twice, right? So there are two solutions here, or I guess the question says more than one solution, but that same explanation applies because the lines intersect twice, even in just this restricted part of the graph that we're looking at from 0, right, from this point 0 out to 2 pi. Okay, that's all we're worried about, but even then we have two intersection points, right? So that's 6-1A, okay? That's part A of that question. Letter B, sort of similar, says how many solutions are there? in this restricted domain? Well, there are two solutions, right? There's two solutions. Okay, and then what are they, is what it says. What are they and how can you find them? Well, we could use these graphs to find them, but I would suggest to you that it may be easier to look at what they do in letter C. Okay, letter C. It says, now recall the unit circle is shown at the right. So let's think about our unit circle for a second. It's right here. Oh, sorry, we're not going to deal with this yet. That's going to get thrown down to later. Okay, but we have our unit circle. And if we look on our unit circle, on your unit circle in your notes, is there a location where the sine value of the angle, sine of x, is equal to a half? Is there a location where the sine of x is equal to a half? Yes, there is. And that location is, I believe, right here at pi over 6, right? Because remember, sine is our y value, so the second number in our parentheses for that point should be a half, right? And then there's another spot. There's another place where the sine of x is equal to a half, and that's over here. This point over here, that one is, I believe, 5 pi over 6. Okay? So these two spots are where the y value is equal to a half. Okay? So one of mine got a little bit high, but that's okay. I can maybe move it down slightly. There you go. Okay? So one thing that we can always do, you guys, is we can draw ourselves a quick unit circle, okay, like this. And then for sine, we draw, oops, that's a bad W, sorry. Draw a horizontal line. Draw a horizontal line at the value on the y-axis, okay? I'm going to say in the y. And then similarly, you guys, we could have equations. Let's say, for example, we had the equation, the cosine of x. Cosine of x, cos x, is equal to 1/2. Okay, for cosine, on our unit circle, we do basically the same thing. We just draw a vertical line at the value, but this time we do it in the x. Okay, because remember, the cosine is the x coordinate on our unit circle. So if I want to know where the cosine is equal to a half, I basically go out to a half on my unit circle and I just draw a vertical line. I draw it up, I draw it down, and I end up intersecting 2 points that are labeled on my graph for me. This one here is, I believe, pi over 3. Sorry, that looks like an H. Trying to make that a little more of a pi. Pi over 3, and then this one down here is, I believe, let's see, 1, 2, 3, 4, 5 pi over 3. This one here is 5 pi over 3. Okay, so for cosine, we can draw vertical lines because we're talking about x values. For sine, we can draw horizontal lines, okay, because we're talking about y values. So cosine of x is equal to a half, we can solve with our unit circle. Now, if I go back up to talking about the sine of x equals a half, remember we're still sort of on part B, although we did just answer part C right here. This is going to be part C. But part B still wants to know what are the two solutions for this equation. So looking at your unit circle, what are the two angles, the two values that we could put into the sine function here to get a value of a half? Well, one of them is x equals, I believe, pi over 6, right? That was the first spot on our unit circle that we saw this as our sine value or our y value of our coordinate point. The other one was 5 pi over 6, just south of 1 pi. Okay, so these two solutions right here are the two solutions for sine of x equals a half in this restricted domain. Remember, we're still in our restricted domain, 0 to 2 pi. Okay, so when you are asked to solve a trig equation like this, you're basically, your two steps are going to be to, number one, get the trig stuff by itself. Whoa, that wasn't supposed to happen. Let me fix that. Undo. Undo. Whoopsies. Click there. Okay, so if we go back to this, so we want to get the trig alone. Okay, that's going to be step one. Get trig alone, and then step two is going to be to use our unit circle. Use the unit circle, and that's sort of what we just explained in part C, right? How can this help us? All right. So we're going to skip over part D for right now because we're going to get to do something very similar to that in just a second. So let's then go on to 6-3. Okay. So number 3 in your book, if I think it's maybe starting on the next page, they ask us now about this equation where they want to know, okay, what about this equation right here? So number 3, I'll say this, I'll say 6-3. They're asking us about sine of x equals 2. Okay, sine of x equals 2. So think for a second about what that means when the sine of x is equal to 2. And remember our 2 steps for solving trig equations like this. Is the trig stuff already by itself? The sine of whatever? Yes, it is. So now we're supposed to use our unit circle. What's the problem with using a unit circle to solve this equation? Well, remember why we call it a unit circle, right? Why do we call this thing right here a unit circle? We call it a unit circle because it has a radius of 1, which means this high point up here, right? This high point is 1, and this low point is -1. So if we're talking in terms of sine, in terms of our y values, where on our unit circle is the sine of x going to equal 2? Well, nowhere, right? There is no point on the unit circle where the sine is equal to 2. None of your coordinate points have a y value of 2. None of them. Because the circle only goes up to 1. So up at 2 would be, you know, way the heck up here, and it's not, the circle doesn't go that high. So 6-3 says, using the unit circle, explain why the sine of x equals 2 does not have any solutions. Okay? So it has no solutions because the highest point is only 1. So we can't get up to 2 because it only goes up to 1, right? We can't also get 1.5. We can't even get 1.1 because it only goes up to 1, and then anything above that is never on the unit circle because that's too high, okay? So 6-3 is sort of showing you that sometimes, actually quite often, trig equations like this are not going to have any real solutions, okay? And we're never going to deal with any other types of solutions for them, okay? So don't worry about that. There are no solutions to this equation right here, where the sine of x is equal to 2, all right? Because the highest point on the unit circle is 1, okay? So sometimes we have no solutions, all right? Now, we're going to take a little bit of time here and talk through some practice. Talk through some practice problems like, okay, well, I'm going to take the cosine of x, and I hope that all comes together. There we go, okay? And then I'm going to take that guy down here. Okay, so if we look at 6-5, problem 6-5 in your book shows us these 4 equations, A, B, C, and D, and they want us to solve these only in the restricted domain 0 to 2 pi, and they write it as these inequalities, 0 less than equal to x less than equal to 2 pi. What that means, you guys, is we're just talking about solutions to these equations on the unit circle, because remember, the unit circle goes sort of up and around 0, up and around to 2 pi. And of course, we could keep going around and around and around, but for right now, we're not going to do that. We're just going to restrict it to one time around the unit circle, okay? Now, each of these, I shouldn't say that because letter C already is, but each of some of these are going to require us to do step one with sort of our algebra skills from like algebra 1, really basic solving equations kind of stuff, okay? So if we look first at letter A, our first step here is to get the trig stuff by itself. So the trig stuff is sine of x, okay? This right here, the trig stuff and then the variable, sine x. I want to get this stuff by itself, which means I need to get rid of this plus 1, okay? So thinking way back to algebra 1, how we used to solve equations, how do we get rid of a plus 1? Well, we just minus 1, okay? We just minus 1 over here, and then here we go. What do I have left? On the left side, I just have sine x. On the right-hand side, I just have negative 1. Okay, sine x is equal to negative 1. So now that the trig stuff is by itself, sine of x, just all alone, just sine of x, I'm going to use my unit circle, and I'm going to think, okay, where on my unit circle? If I just draw myself a quick one here, I apologize if this is absolutely terrible. I mean, it wasn't 100% terrible. I mean, it's pretty bad, but whatever. If I think about my unit circle, where on the unit circle is the sine value equal to negative 1? I think there's only one spot, and I think it's right down here. It's right down here at, and then what angle is this? Again, we're going to answer these on our unit circle with exact answers in terms of pi. So because sine of x is equal to negative 1, I know that the only value of x that works there has to be 3 pi over 2. Okay? So this right here is my solution to this equation. X equals 3 pi over 2. That's one that only had one solution, only one answer. X is equal to 3 pi over 2. Okay? Now, if we look at letter B, they're talking about cosine, and they've done something a little bit different. They don't have anything added or subtracted after the cosine of x. They actually have something multiplied in front of the cosine of x. It says 2 times the cosine of x is equal to negative 1. So how do I get the trig stuff by itself now? I need to undo the multiplying by 2. So if I divide away this 2, that's going to leave me just with cosine of x. Okay, so cosine of x, and then of course I need to divide away the 2 on this side. I end up with a fraction. It says negative 1/2. Okay, so now I'm thinking unit circle. Okay, I'm thinking unit circle. I'm thinking, where is the cosine equal to negative 1/2? Well, remember, cosine on my unit circle, I want to draw a vertical line, right? Vertical line. So if I go to negative 1/2 and I draw myself this vertical line on the x-axis, right, vertical line, I hit 2 points on my unit circle. One is up here and the other is down here. Hopefully you can see on your unit circle what those values are in terms of pi. I believe that top one is 2 pi over 3. So x is equal to 2 pi over 3. And then the other one is down at the bottom. That's going to be 4 pi over 3. Okay, 4 pi over 3. So these two answers now are solutions to this original equation. That if I do the cosine of this value times 2, I'm going to get negative 1. If I do the cosine of this value times 2, I'm going to get negative 1. Okay, so these guys right here are my solutions. Okay, now what I would like you guys to do is I would like you guys to do letters C and letter D on your own. Okay, now letter C is slightly more difficult because it's not one where we can just go in the unit circle and draw a vertical line. But we should see radical 2 over 2 on our unit circle a lot in our coordinate points, right? Those are at all the pi over 4s. So I want you to find the spots where the cosine, meaning the x value in that coordinate point, is negative 2 over 2. Tell me those two solutions. Okay, and then here, we actually have to do 2 things to get the trig stuff by itself. We have to add a radical 3, add radical 3 over to here, and then divide away the 2. So if I help you out just a little bit, this one's going to end up looking like this, radical 3 over 2, okay, when we get the sine x by itself. And then you're going to use your unit circle again to find where are the x values, where are the points that the sine of x is equal to radical 3 over 2, okay? So I'd like you to do C and D, finish out problem 6-5, and then I've given you a couple extra practice problems, I believe. If you're having questions or confused about anything in terms of how we use the unit circle to solve trig equations or what it really means or looks like to solve trig equations, do please reach out to me at some point. I am relatively available for you. Slightly less available now that I have a small child at home, but I am still really available as much as I can be for you guys to answer questions and things like that. So please reach out if you need to. Otherwise, that's all I have for you right now, and we'll talk to you soon.